Alright, so we're going to finish up notes from section 4.4. But there are a couple things that I want to go over with you that are not on your notes. So you might want to add this to the back of your notes. Okay, and the first thing I want to do is I just want to refresh your memory on if you had a fraction like 2 radical 2, or 2 over radical 2, sorry. And when you had this before, you always had to rationalize it, right? Okay, so to rationalize this, I got to get the radical out of the denominator. So I'm going to multiply top and bottom by radical 2. Okay, so in the numerator, when I multiply, I'm going to have 2 radical 2. And in the denominator, radical 2 times radical 2 is just going to be the whole number 2, the integer. Okay, so now that you have the radical gone out of the denominator, you want to reduce whatever you can reduce. And remember, it's just factors that you can reduce, right? So these 2's, those are both factors, so I can reduce those. And all you're left with is the square root of 2. Okay, so we're going to be doing something similar with the i's in the denominator. We're going to have to rationalize the i's when we get those. Okay, the other thing I wanted to kind of talk about is, since you've been factoring, you have these type of problems, binomials, where you have a difference of 2 squares. The first term is a perfect square, the second term is a perfect square, and there's no middle term. This is, I'm sure that you guys have remembered how to factor this. You can take the square root of the first term, square root of the last term, and the signs in between have to be opposite each other. And that's why you don't get that middle term, is because you have a minus in one and a plus in one of the binomials. Okay, so this is called a pair of conjugates whenever you have identical terms, but one's a plus and one's a minus. So difference of 2 squares you can always factor into a pair of conjugates. Any questions? Okay, so let's do this example. It's not on your notes. 2i over 1 plus I. I can't leave the I in the denominator, so I have to rationalize this fraction. And 1 plus I is a binomial. Okay, so the way that I get rid of I when it's in a binomial is by multiplying top and bottom by the conjugate. So I'm going to use the identical terms, 1 and I, but it's going to be minus. If you start with a plus, you got to use the opposite sign to make it the conjugate. Okay, so in the denominator, there is a shortcut to multiplying conjugates together. But this is it only works when you have a plus and a minus with identical terms. Okay, you could FOIL it together, but the middle term is always going to add to be 0. You're always going to get rid of it. So what you could do is square the first term, square the last term, and subtract them. That's the way it always works out. And just to illustrate that, let me multiply these two using FOIL. Okay, so I'm going to multiply the first terms, the outer terms, the inner terms, and the last terms. So negative I plus I, that's 0, and all you're left with is 1 minus I squared. That only works with conjugates. Okay, so the top part I'm going to have to distribute the 2i. We have 2i minus 2i squared, and I have to simplify everything, of course. My I squareds are actually what when you simplify them? Negative 1. So this bottom part, I'm going to have 1 minus a negative 1, which is 2. And the top part, this I squared times negative 2 makes that whole number equal to what? Positive 2. That's right. You have negative 2 times negative 1 makes it a positive 2. So also when you're writing a complex number, you always want to start with the real part of it. So I'm going to put the 2 first and put the I second. Okay, so this 2 plus 2i is all one number. It has to stay together. But if I can take out a common factor, I want to do that and see if I can reduce something. And they both have a 2. So I'm going to take the 2 out of both of those numbers, or both of those terms in the numerator. 1 plus I. It's all over 2. So now I can reduce the 2's because this 2 is a factor in the numerator. And all you're left with is 1 plus I for your answer. Okay, any questions?
Off of the second part where you do 1 squared minus I squared, how did you get the 1 squared if you got it? Or you boiled it, you got 1 minus I squared?
1 times 1 is 1 squared.
Uh,
It's just I didn't write it down because it's just a 1. Anything else? All right, here's another example. This one you're going to have a monomial in the denominator that has I. This one's a little bit easier because you don't multiply by a conjugate when you have a monomial. To get rid of this I just need to multiply top and bottom by I. Because when I multiply I times I, that gives me I squared, which is a negative 1. So it's going to reduce out when I multiply by just an I. But in the numerator, I have to distribute that I. So in the numerator, I'll have 5I plus I squared over 3I squared. Okay, and then of course I want to simplify. This I squared is negative 1, and when I write the complex number, I want to put that first. And in the denominator, 3 times I squared, or 3 times negative 1, is going to be negative 3. Okay, so you could leave your answer like that. It's not wrong. It's not in simplest form, really, but it's not wrong. Since you have these two negatives, I can factor a negative out all the way across this binomial in the numerator. So it would look like this. If you factor a negative out, I'll just make it a negative 1. Okay? You'll have a positive 1 minus 5i in the numerator. Factor a negative 1 out of the 3. So you can reduce those negative ones, and you're left with 1 minus 5i over 3. And so you could write it like that too.
Do we have to put the parentheses when we write that?
I like to put parentheses there because it helps me remember that it's all one number, and I can't just pick and choose between these two that I'm going to reduce something. That's why I like to put parentheses, but no, you don't have to. Okay, any questions? All right, let's look on the other side. Back on your notes, looking at number 17, we are going to solve for x. We have 3x squared plus 48 equals 0. Okay, so I have a squared variable and a constant. I don't have a linear term. So when I have an equation like this, I'm going to use something called the square root property. And this only works for square roots, because that's the name, square root property. So to do that, I'm going to separate these two values. I'm going to subtract the 48 to the other side. Now I want to get the x all by itself, so I'm going to divide each side by 3. That's x squared equals negative 16. Okay, in the next step, since I have x squared, to get just my x, I'm going to take the square root of each side. Okay, and what's the square root of negative 16? This negative is going to give you an I, but what's the square root of 16? 4. Okay, so x is going to equal 4i. Now one thing about this, since you're taking the square root to solve for x, you have to put plus or minus for your answer because it could be a positive 4i, it could be a negative 4i. Okay, so in your book, if they've given you the problem like the square root of 4, okay, that they're asking you to find the positive root of the square root of 4. So that is just 2. But when you are solving the problem and you take the square root, you have to put plus or minus in front of your answer. Okay, if you don't, then you're going to get part of it wrong. All right, let's try another one. Let's look at 19. Is everybody finished with this one up here? Okay. Number 19, 4 over 5 x squared plus 1 equals 0. So first I'm going to subtract the 1 over. And what am I going to do now to solve for x squared? To get multiplied by the reciprocal. Okay, so I'm going to multiply both sides by 5 over 4. So I have x squared equals negative 5 over 4. You only need the negative one time in your fraction. And I'm going to keep it with the numerator so it'll simplify easier. Okay, so now I'm going to take the square root. I'm going to have the square root of negative 5 over the square root of 4. I'm going to put the plus or minus in front. And I can simplify the numerator by taking out the I. And the denominator is just going to be 2. So that would be your answer. Any questions? Okay, let's look at number 20. Number 20 says if two complex numbers are equal, so I have 2x plus yi, that's one complex number, and it's equal to negative 14 minus 3i, the other complex number. So if two complex numbers are equal, then the real number parts are equal, and the imaginary parts are equal. Find a value for x and y that will make the statement true. So on the left side of the equal sign, the 2x is your real part because it does not have an I with it. So this is the real part on the left side. On the right side, the negative 14 is the real part because that one doesn't have an I with it. So I would set the real parts equal to each other and solve for x. X is going to equal negative 7. And then set the imaginary parts equal to each other. So the yi, negative 3i, those are my imaginary parts. So I'm going to set those equal to each other. Divide by the I to isolate your y, and you'll get y equals negative 3. Okay, so really you don't have to write the I down in your equation because it's going to reduce out anyway, and that could save you a step. Any questions? Okay, let's do the last one, 21. 2x minus 3 plus parentheses y minus 4i equals 3 plus 2i. Okay, so the real part on the left side is this 2x minus 3 because it does not have any i's with it. And it's going to equal 3 on the right side. Let's solve that for x. And the imaginary parts on the left side is y minus 4, and that's going to equal 2 on the right side. I'm not going to put the i's in there because they're going to reduce out anyway. Yeah, I'm not going to put the i's in there because they reduce out anyway. So you're going to have y equals 6.